vast terrain of southern China lies evidence of giants. 2 million years ago, these giants roamed the forest in large numbers until their populations dwindled, and now they only exist in fossils and folklore. We find evidence of these giants in hard rocks deep in the caves. This giant towered over other known primates at 3 meters tall and weighing in at around 250 kilograms. A very distant relative to humans, Gigantopithecus blacki, more closely related to orangutans. They were thriving until they abruptly disappeared. So what brought down this mighty beast? Our understanding of this species is from just teeth and jawbones, so there has been a concerted research effort to find the missing answers to this mystery.
My professor and our team has been working in this area for more than 10 years. If you want to find out the extinction of Gigantopithecus, you cannot just look at the caves that have Gigantopithecus. You also need to look at the caves that they don't have Gigantopithecus.
A team of Chinese, Australian and American scientists have been excavating in the hard cave sediments since 2015, trying to find clues to its extinction. What's really exciting about this cave is that this was the cave where they first found Giganto. So this really is the starting point for us. This is really the crucial cave where we can really find out how old Giganto was, the fossils that they found. But also, what's interesting is we have Giganto in the bottom layers, but in the upper layers, there's no Giganto. So that would be really interesting for us to find out exactly when Giganto just dropped out of the fossil record. The team explored hundreds of caves in the Guangxi province in southern China, and 22 of the caves with the best evidence were excavated and samples were collected for dating.
Up to now, there has been only 3 mandibles of Gigantopithecus found in the caves of southern China. We left a tooth on the wall here. So this is the layer where we found the 4th mandible of Gigantopithecus.
The exact timing of extinction is crucial to establish so that we can target a precise period of time to look at how the environment was changing and how the species was behaving. We focused on both sediment and fossil dating.
And we're finding loads and loads of fossils within this what we call fluvial sediment, a conglomerate. So we can date this with optically stimulated luminescence, or OSL dating, and we can work out exactly when this sediment was last exposed to daylight before it was deposited in the cave.
But sediment dating alone is not enough to establish the timing of extinction. We need to support the sediment chronology by directly dating the fossils themselves.
So we do direct dating of the teeth. So there's 2 techniques basically we can use. One is U-series. Usually you can drill with the laser and measure the uranium content and thorium content, and then you can work out the age of the tooth. Or what you can do is also remove a fragment and do what we call ESR, which is electron spin resonance, and we measure the number of electrons that have been trapped over time in the enamel. One of the techniques that I especially do is combine the 2, uranium and ESR, to actually get an accurate age of ESR U-series.
Combining over 150 radiometric ages, the team established that Giganto went extinct between 295 to 215,000 years ago. But how is the environment changing at that time?
We're really interested in working out what the environment was like when Gigantopithecus was roaming the landscape. And so there's many ways you can do that, but one of the interesting ways to do it is to look at the sediments preserved in the caves, and then take them to a laboratory and try and extract microfossil remains from them. And these microfossils can include things like pollen, which can tell you a lot about the vegetation that was growing around the cave at the time it was deposited, but also charcoal as well. And the charcoal can tell us quite a lot about how much burning was happening in the landscape.
We have to realize, in the past, those caves were actually fissures or sinkholes in the ground, and this whole area was a subtropical rainforest with a high canopy. And Gigantopithecus more than likely traversed the forest floor, eating fruit and other objects on the floor that Giganto could find. But above Giganto, up in the trees, we would have found the orangutans.
The final puzzle in this research was looking at how Giganto was behaving during our window of extinction.
What we try to do is maximize the information we can get from each tooth. So what we're going to do is we're going to use that as well to trace their diet, their trophic level. We're going to look at the potential migration and radius of migration of those individuals.
From these extensive data sets, it's clear that early Giganto was flourishing in a rich and diverse forest. But by 600,000 years ago, the environment became more variable due to the strengthening of the seasons. This caused a change in the structure of the forest communities and an increase in disturbance. Despite being a close relative of Giganto, orangutans were able to adapt their size, behavior and habitat preferences to these changes. In comparison, Giganto relied on a less nutritious backup food in times of food scarcity, so the diversity of its food decreased. Its increase in body size restricted its geographical range for foraging, and this all contributed to chronic stress and dwindling numbers. This is a glimpse of a species on the edge of extinction. The story of Giganto is a lesson in extinction, in how some species are more equipped to survive change and others are more vulnerable. This was the end for the vulnerable giant.